Hi class. Today we're going to discover 3 more properties of exponents: product of powers, power to a power, and power of a product. In your book it's section 7.3. We're going to expand these expressions to see what kind of good stuff we find. So I've got 2 to the third power times 2 to the fifth power. Now, what is the base of 2 to the third power? Okay, it's just 2. What is the base of 2 to the fifth power? It's just 2. 2 times 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 2. Okay, this is my 2 to the third power. This is my 2 to the fifth power. And when I simplify that, that will give me 2 to the eighth power. Okay? What I want you to notice is that the base stayed the same, but the exponent is really the sum of 3 and 5, because 3 plus 5 equals 8. You can see how that works. Okay, let's try this. What is the base of my first factor? It's x. The base of my second factor is x. But let me ask you, what is the exponent of my first factor? All right, that's 2. What's the exponent of my second factor? If there's nothing, then you better put a 1 on it. Bam, it's 1. Okay, so we'll just keep that in mind. So if I were to write this out, if I were to expand it, I would get x times x, okay, times x. That's my x to the first power. And that gives me x to the third power. And my pattern's working out because 2 plus 1 equals 3. Here we go. Now I've got 2x to the third times 5x squared. Let's see, what is the base of 2x to the third? Well, I know that my exponent is 3. Who does that 3 belong to? It belongs just to that x. So that's got a base of x. Who does this 2 belong to? X. This also has a base of x. So when I write this out, I end up with 2 times x times x times x times 5 times x, and I can rearrange my coefficients variables because multiplication is commutative. So I'm going to move my 5 over, so I'm going to end up with 2 times 5 times x times x times x times x times x, and if I simplify that, 2 times 5 is 10, okay? So I'll end up with 10 x to the fifth power. And you'll notice that I kept my base the same. Okay, my base is x, and I ended up adding the exponents because 3 plus 2 is 5. Right? I still multiplied my coefficients like normal. Okay, let's try this one. X to the third power, y to the second power, times x to the fourth power, y to the third power. Okay, I'm going to rearrange this so that all these x's kind of come over here. So can you visualize that? I'm going to end up with x to the what power? X to the seventh power. Okay. And I'm going to move my y's like over here. And I'll end up with y to the fifth power. You'll notice that my rule still holds true. Whenever I had the base of x, I added the exponents, 3 plus 4, and I got 7. Okay. Whenever I had a base of y, I added the exponents, 2 plus 3, and I got 5. So when I'm multiplying factors with the same base, what happens to my exponents? I add them. I only add the exponents for the same base. So now the rule that we just discovered is one of our rules, one of our properties of exponents. Here we go. It's called the product of powers rule. If I have one base raised to some power, multiply by that same raised to another power or any other power, okay? My answer, when I simplify it, is going to be x to the m plus n, whatever that happens to be. Okay? This is a product, because I'm multiplying, of powers. Right. Now you use that rule, use that shortcut, okay, and see if you can simplify these next three. Pause me and come back when you're done. Good, now we're going to simplify a power to a power. That's my personal favorite, a power to a power. Let's expand it and see what we discover. I've got fourth to the third power, and I'm taking that all to the second power. Okay. So I know if I take anything to the second power, if I square anything, it's just that multiplied by itself. So I've got 4 to the third power times 4 to the third power. Okay, that's 4 to the third power squared. If I expand that thing out, I end up with 4 times 4 times 4, which ends up being 4 to the 6th power. But I could have used that rule I just discovered because both of these powers have the same base. Okay? And so I know if they had the same base, all I have to do is add the exponent. Okay? And that also would have given me 4 to the 3 plus 3 is 6, 4 to the 6th power. So that was a faster way to do that one. Let's try the next one. I have x to the 5th squared. So I could have x to the 5th times x to the 5th. And I can write the whole thing out. But I can see that it's really giving me x to the 10th power. Could have used my shortcut because I've got the same base. All I need to do is add exponents when I'm multiplying. So here we go. So that would give me x to the 10th power. 5 plus 5 is 10. What I want you to notice here is that there's a relationship. When I've got a power to a power, there's a relationship between these exponents and then the exponent that results when it's simplified. Do you see a relationship between 3, 2, and 6? Or 5, 2, and 10? If you see that relationship, go ahead and guess what a to the 8th cubed to the 4th power would be. Okay, now I'm going to for you. Here we go. So it's a cubed times a cubed times a cubed times a cubed. And I know that if I have the same base, all I have to do is do what? Add the exponents. So that would be 3 plus 3 plus 3 plus 3. And that gives me a to the 12th. Is that what you guessed? Okay. Hopefully you see that 3 times 4 is 12. 5 times 2 is 10. 3 times 2 is 6. We've discovered a new property, a new shortcut. So when raising power to the power, what happens to the exponents? Okay. I'm going to multiply the exponents. If you need to rewind me and watch that again, that's fine. Go ahead. Okay. So the new rule that we discovered is called a power to a power, is written formally like this. If I have a base, which is raised to a power, and I raise that whole thing to another power, the property tells me that my result is going to be x to the m times n. M times n. Power to a power because my base is a power. This whole thing is a power. All right. So now let's, you try these on your own. You can expand them if you want to, or you can use the rule, either one. Or you can do them both to make sure that you understand. Pause me and come back when you're done. Okay. Now we're going to learn how to simplify a power of a product. So here's the power part. Okay, it's an exponent. This is raised to the power of 3. And here's the product part. A product is just 2 or more factors multiplied together. So this is a product. 2 times x. It's a product. Okay. So let's expand it, see what we discover. So this is going to be 2x times 2x times 2x. which I'll rearrange it so that my coefficients are together. That'll give me 2 times 2 times 2 times x times x times x. Now right now, I know in your head you probably want to take this and change it to 8 because 2 times 2 times 2 is 8. Okay? But just to demonstrate this property to you, I want to show you the step that goes in between. So here I go. So I'm going to rewrite this as 2 to the third power times x to the third power. And what I want you to see is that I basically applied this power to each of the factors of my product. Okay? It became 2 to the third power times x to the third power. Let's try the next one. This will become negative 4x times negative 4x. I'm going to bring my negative, put them together. So I'll have negative 4 times negative 4 times x times x. Okay. Now I'm going to just term step once again. So this will become negative 4 squared. Remember, it's got to be in parentheses if I'm using exponents. Okay. Times x squared. Notice negative 4 squared times x squared. There's a shortcut that we're discovering. Let's try this one. I've got 3x squared times 3x squared times 3x squared times 3x squared. I want you to look at this base because the base is 3x squared. We can see that. Okay. All right. Let's rearrange. I'm going to end up with 3 times 3 times 3 times 3. So I'll rewrite that as 3 to the fourth. And then I'll end up with x squared times x squared times x squared times x squared, which I'll write as x squared to the fourth power. Do you see that? These are my two factors. One is 3 and one is x squared. I'll end up with 3 to the fourth power times x squared to the fourth power. Now I know this isn't completely simplified yet because I've got a cool power to a power here. So if I've got a power to a power, I know I will end up multiplying. Okay, so I'll end up with 3 to the fourth power times x to the 2 times 4 is 8 power. That'll be my end result. But I used the shortcut of product to get me there. Okay? So when I raise a product to a power, how is the exponent applied? Let's see. Each factor of the base is raised to the exponent. Okay. So my rule for power of a product is if I have some product, I'm just putting a times b because that's two things multiplied together, and I raise it to a power, that's the same thing as a to the n power times b to the n power. Use that rule to simplify the next three expressions. You can expand it out also to make sure that you're right. Pause me, come back when you're. Last thing we're going to do is I just want you to practice a couple of things that we've learned in prior classes. Remember how important parentheses are and what difference they make. Think about what happens when we have a negative exponent or a zero exponent. And when you're done with this, you are done. Great job. I'll see you in class.